All right, hello, my gems. Today we are going to talk about perimeter and area on the coordinate plane. So at this point, we have now talked about points, lines, and planes, and we've talked about segments as well. And remember, a segment is just part of the line that you can physically measure, right? It's got a starting point and an ending point, and it doesn't go on forever. A line would go on forever, but segments don't. So we're today going to talk about different segments, and we're going to talk about the perimeter and the area of them. Now, perimeter of a polygon is the distance around the polygon, and it can be found by adding all the side lengths together. So think about if you had like a lawn, let's say, the amount of like grass in your lawn, that's the area of your lawn. And then if you were to put a fence around the lawn, that would be the perimeter. So perimeter is the distance around. And because we're talking about distance, we are going to calculate unknown side lengths of the polygon using the distance formula, or Pythagorean theorem, which is a squared plus b squared equals c squared, only if we have a right triangle. If we have a right triangle, we can use that. If not, we're going to use the distance formula. And remember, Mr. Masco kind of gave you guys that little cheat for the distance formula, where instead of doing this, you could do the change of x squared plus the change of y squared. And I like to do that just because I think it makes it a little bit easier. Okay, so we're going to start by finding the perimeter here of our quadrilateral EFGH. We're going to round to the nearest tenth. So I know that we've been practicing reducing our radicals. For today, because we're actually talking about a real distance, we're going to actually use the calculator and we're going to actually put it in. Okay, so we're going to start just by graphing our coordinates here. And when you graph, remember the first number tells you your x coordinate, which is left or right, excuse me. And then the second coordinate tells you your y, which is up or down. So EFG is for -1, -1, -2. Okay. So here's my quadrilateral, EFGH, and I'm just going to connect them, make it look really nice. Okay, now this quadrilateral, unfortunately, if you look at it, you'll notice none of the side lengths are the same, right? It's not like a rectangle or a square where some of our distances are the same. Unfortunately, this one has 4 different sides, which means we're going to have to find the distance of all 4 of these sides, and then we're going to add them together to get my perimeter. Okay, so we're going to start by finding the length of EF. So EF is here to here. So that's my first length. And remember, we're going to use our distance formula. And when I do my distance formula, I'm going to do change of x squared plus change of y squared. Right? So thinking about it like we're on a number line. So if we're going from E to F, remember, we look at our x values, see how they change. So if you're going from -2 to +4 on a number line, you're really adding 6. And then if you're going from 6 to 3, you are subtracting 3. So now that I got my differences, I'm going to do 6 squared gives me 36. And then -3 squared means -3 times -3, that's a +9. When I add those two together, I get the square root of 45. And then I'm going to put it into my calculator to get an approximate distance or an approximate length. So when you're putting it in your calculator, you're going to push 45. And then remember, to get the square root symbol, you're going to push shift and then x squared. So my answer is about, we'll round to our tenths, about 6.7. And because we're talking about a distance, I need to have some kind of label. So we're just going to label it units. Okay, so there's the first length. Second length is the length of FG. So I'm going to come back to my picture here, and what I notice for FG is this is a vertical line. And because if it's perfectly vertical or perfectly horizontal, you can just count the boxes. You don't actually have to do the distance formula. So if we're just counting from F to G, that's 1, 2, 3, 4 units away, or 4 boxes away. So I'm not even going to do the distance formula for this one. I just know it's 4 units. Just lovely. One less thing I got to do. Next one is from G to H. G to H. So that is this bottom one here. Okay, so I'm going to go from, I guess I'll go from G to H. So I'm going to start with G and end at H. So again, same thing, distance formula. Okay, so if I'm going from G to H, if I look at my X coordinates to go from 4 to -4, I'm really subtracting 8. Okay, we're thinking about a number line. And then if I'm going from -1 to -2, I'm just subtracting 1. Okay, so now we do our exponents because that comes next in order of operations. So -8 squared means -8 times -8. That is a positive 64. And -1 squared means -1 times -1, which is a positive 1. So I get the square root of 65. And again, I'm going to put that into my calculator by pushing shift x squared, and I get about 8.1 units. Okay, and now I'm on to my final one, which is the length of EH. Notice it's the same thing over and over and over again. Never ends. Okay, so I'm going to go from E to H when I do my distance. Okay, so here's E, here's H. So if I'm going from -2, if I'm looking at my X values, from -2 to -4, I am subtracting 2. And then for my Y values, if I'm going from a +6 to a -2, I'm really subtracting 8. And then I square my answers. So -2 squared is 4. -8 squared is a positive 64. Add them both together, I get the square root of 68. And then one more time into my calculator, I push 68 and then I push shift x squared. So I get about 8.2 units. Okay, now the final step to find the full perimeter is to add all 4 side lengths together to get my perimeter. So I'm going to add together 6.7 plus 4 plus 8.1 plus 8.2. And when I add that all together, I get a total of 27. And we're talking about units because we're talking about distance. So it does have to have some kind of label. I didn't give you like inches or anything, so you can just put units. Okay, and there we go. That's it. That is perimeter on the coordinate plane. So you're finding the distance between 2 points that make up a side length, and then you're adding together all of the sides together. So it is very repetitive. You're kind of doing the same thing over and over again. I'm going to let you guys try number 2. So if you want to pause the video and give it a go, you can do that. So pause it here. And then I'm going to show you my answer now. So that way you can check yours with mine, see if you did it correctly. You should have gotten, well, first thing you should have done is written out the coordinate points, because if you don't write out the coordinates, you're not going to be able to find the distance between the points. And then just like before, I found the distance between each one of the endpoints. So from G to J, excuse me, I got about 7.6 units. From G to H, I got about 8.1 units. And from J to H, I got 5 units. So when I added them all together, I got 20.7 units. Okay. Example 3. I should have, sorry, give me 1 second. Okay, I forgot to label these, sorry. All right. So example 3, it says find the perimeter of triangle GHH using the Pythagorean theorem. Note, this only works for right triangles. So you have to have a 90-degree angle in a right triangle in order to use this theorem. If you don't, then you're not allowed to use this theorem. This is the only time you can use it. Now, if you remember the Pythagorean theorem, It is a squared plus b squared equals c squared. Now, what that refers to are the three sides of a right triangle. The only one that's really important is the C value. My C value is the one that is across from the 90 degrees. It's the longest side. It's called the hypotenuse. So if you go to the 90, you go directly across. This side's called your hypotenuse. And whenever you use this formula, your hypotenuse must be the C value. Must. Okay, has to be that. The other two, the A and the B, are the other two sides of the triangle, and they're called the legs of the triangle. So think about you've got two legs, and a triangle has two legs. And it doesn't matter which one goes where, but you put the two lengths of the legs in your A and your B values. You put the length of your hypotenuse in your C value, and then you would essentially solve it like an algebra problem for whatever it is that you're missing. So in my picture here, what's beautiful is that because it's a right triangle, I have some vertical and horizontal lines. And when you have vertical and horizontal lines, you do not have to do the distance formula. All you have to do is count. So in this picture, my legs are GH, this is a leg, and HJ is another leg. The hypotenuse in my picture is the one across from the 90, it's the diagonal. It's this side over here, G to J. Now, if I just count, right, if I say, okay, I'm going to count from H to J, that is that's 7 units across. So one of my legs is 7. So over here in either the A or the B, doesn't matter. I'm going to put a 7 in because that's the length. Plus, now I'm going to find the other leg. 1, 2, 5, 6, 7. Oh, that was nice. Also comes out to be 7. And then I have to solve for the hypotenuse. I'm trying to figure out, okay, what is the length of that hypotenuse so I can figure out the full perimeter of this shape. Now, this is just an algebra problem. It's easier than it looks. First thing I'm going to do is, in my order of operations, there are no parentheses, so I'm going to do exponents. 7 squared gives me 49. Another 7 squared gives me another 49. I add together my two 49s to get 98, and I'm almost done. I have 98 equals c squared, but in order to get c by itself, I have to get rid of the squared, which is a square root. That will cancel it out. So the square root of 98 is about 9.9. So my C value is about 9.9. So that means from G to J, this is about 9.9 units or boxes away. So now to find my perimeter, because that's what the question's asking for, is the perimeter, I'm going to add together all three of the sides. So I know this leg was worth 7. This leg, G to H, was also worth 7 units. And then my hypotenuse, G to J, was worth 9.9. So if I add those all together, my perimeter is 23.9. And I put units because, again, got to make sure I'm labeling for perimeter. Okay, so there you go. That is perimeter. So in order to find perimeter, we're adding together all the side lengths together, and they have to use either the distance formula if it's any shape other than a right triangle. If it's a right triangle, you can use the Pythagorean theorem, but you are not required to. You can use distance formula for all of them. Okay, now we're going to go to our second section, which is area on the coordinate plane. So remember I said at the beginning, area is like the amount on the inside. Like if you're thinking about a lawn, it's how much grass you have. The perimeter is your fence that you put out around it. So the area of a polygon is the amount of space inside the boundary of the polygon. You can again calculate unknown side dimensions using the distance formula or the Pythagorean theorem. But once we have our side lengths, what we're going to have to do is take them and plug them into the area formulas. There are different formulas you must know in order to find the area of a square, triangle, right? All the ones that are listed there. So the ones that you're most likely going to use are triangle, which is base times height divided by 2. You're going to use a rectangle or a parallelogram, right? Length times width or base times height. That means the same thing. Circle is pi r squared, and trapezoid's kind of crazy. It's 1/2 of base 1 plus base 2 times the height. It's a little wild, but we'll get to that one eventually. All right, let's try to find the area of the rectangle that is given there for us. So first thing we're going to do, just like before, we're going to graph this bad boy. So again, remember the first number tells you left or right. The second number tells you up or down, and then label your points. So take a sec. Okay, now what is really nice about this problem is if you read the question, it says that this is a rectangle. And since you know a rectangle has like two sides that are congruent to each other, so side EF is the same as side HG, you only have to do it one time. Same with side FG is congruent to EH. So you can choose to do either one of them because it's a rectangle. You got sides that are exactly the same. Okay. So the the area formula for a square, or excuse me, wow, Mr. Masso, oh my God, the area formula for a rectangle, excuse me, is length times width, right? So my area is length times width, which means I need to figure out what this length is and what this width is. So of course, just like before, I have to use the distance formula to find the length or distance between these 2 points. So you can go from E to F, or you can go from H to G. They're both going to give you the same answer. I'm going to choose E to F because those are like positive numbers. So I'd rather work with positives. So I'm going to do from E to F. So again, remember my distance formula is change of X, so squared plus change of Y squared. So if I'm going from E to F, look at the X values. From -2 to +4, I'm adding 6. And then from 6 to 3, I am subtracting 3. So 6 squared is 36. -3 squared is 9. I add those two together, I get the square root of 45. And again, I put it into my calculator, 45, and then I push shift square root. And I get about 6.7 units. So I've got my length. Now I need to figure out my width. So I can either do E to H or F to G. I'm going to go again for F to G just because there's more positive numbers and I would prefer to do positives. Okay, so distance formula is change of X and change of Y. So to go from 4 to 2 for the X's, I am subtracting 2. And to go from 3 to -1, I'm subtracting 4. Okay, square my numbers. -2 squared is 4. -4 squared is 16. Add those two numbers together, I get the square root of 20. And then I put that in my calculator, shift X squared. I get about 4, we'll say 4.5 units. Okay, last part is to find the actual area. So remember, our area is our length times our width. So I now need to multiply my length, which was 6.7, times my width, which was 4.5, and that's going to be my answer for my area. So 6.7 times 4.5. Okay, so my area equals 30.15. And now because we're talking about area, we had multiplied units times units. That means my answer is in units squared. So perimeter is in units, area is always in units squared because you're multiplying units times units. Okay, on to the back. Now, there are a lot on the back. I'm only going to do one with you, and then I'm going to put the answers up to the other ones for you to check. But what we're going to do on the back is find the area using a different method. So on the front, what we did was we found the lengths, right, of the sides, and then we took those numbers and we plugged them into the area formula. What I'm going to show you now is called the box method. And this one works with any shape, but you don't need to necessarily know the area formula. So here's what happens. What I'm going to do is I'm going to draw a box around my shape. I'm going to find the area of the whole box, the whole thing. And then I'm going to take away the pieces that are not included in the shape. So essentially, I'm finding the whole box like a rectangle. I'm subtracting the pieces that are not inside the shape, and whatever I'm left with will be the final area of the polygon. So there are 4 steps to this. Step 1, we're going to draw a box, and when I say a box, I mean a rectangle. I'm not talking about like a crazy shape. I need a rectangle. So I'm going to draw a box around a polygon that has to touch each vertex. It must touch each vertex for this to work. Number 2, I'm going to find the area of the box, and because it's a rectangle, I'm doing length times width. If you do it correctly, if you draw your picture correctly, you're going to then create some outer triangles. And then you're going to find the area of the outer triangles by doing base times height and dividing by 2. From there, you'll subtract the area of the triangles from the area of the box. So like that extra piece, we'll take those all out, and what's left over is the area of my remaining polygon shape. All right, that's a lot. So here's, oh, whoa. Sorry. Okay, so step 1, we're going to draw a box around the polygon that touches each vertex. So has to go. I'm going to do it in a highlighter here. It's going to go through all of the points and make a nice big rectangle. And it's got to go through all of the vertices. Okay. Now what I'm going to do is I'm going to ignore this inside trapezoid here. And I'm going to do step 2, which is to find the area of the box. Now, the box is length times width. So because this is just a straight up box, all I have to do is count, which is the beauty of this. So I'm going to count the length. I'm going to count the width. 2, 3, 1. Okay, so I've got, this is worth 9 down here. Oh, nice. This is also worth 9 over here. So to find the full area of the box, I don't think I have an orange. This was step 2. Okay, so the area of the box is length times width. And we said our length and width were 9 and 9. So 9 times 9. My area of the box is 81 units, and because it's area, it's squared. Okay, great. So now we figured out this whole entire thing. What I now need to do is subtract these pieces on the outside, and that's going to leave me with the area of this polygon in the center. So I'm going to label, I'm going to number my boxes, or sorry, my triangles, just to keep myself kind of like organized. So I'm going to call this one over here on the right triangle 1. Triangle 2 is this small one, 3 is upper left, and 4 is upper right. Okay, so now step 3 is we're going to find the area of the triangles. And remember, to find the area of a triangle, you do base times height divided by 2. Base times height divided by 2. Okay, so if we're looking at this one over here, triangle 1, again, because these are vertical and horizontal, all I have to do is count my base and my height. So in box or in triangle 1 here, from C to the edge over here, I'm going to count. And obviously I know this whole thing's 9. So that means this is worth 8 right here. So my base is worth 8. And then my height is worth 7. So my base is 8 times 7 is my height. Oops, sorry. And then I divide by 2. So 8 times 7 gives me 56, and half of 56 is 28 units squared. So I have now figured out the area of this triangle right here, triangle 1. Okay. Now I'm going to find the area of triangle 2. It's this little one over here. So I've got the base is from D to this point, or you could say this is the base and this is the height. It doesn't really matter. So this is just 1, and then this is 1, 2, 3. This is worth 6. So it's a 6 and a 1 for my base and my height. So 6 times 1 is 6, and half of 6 is 3 units squared. So I've now figured out my second box. So that's box or triangle. Wow, I keep saying the wrong thing. I'm sorry. That's the second triangle, triangle 2. Now I'm going to do the same thing for triangle 3. Okay, so triangle 3, again, we're just counting from A to this point. That's 1, 2, 3, 4. And from here to D is 1, 2, 3. So 4 and 3 will give me this one over here. So 4 times 3 is 12, and half of 12 is 6 units squared. Okay, and now I've got one more left. My final triangle, triangle 4. It's very loud out there. Okay, triangle 4 again, just counting. So this is 1, 2, and this is 1, 2, 3, 4, 5. 2 and 5, and that gives me this area here. Okay, so 2 times 5 gives me 10, and half of 10 is 5. Okay, so we now have the full area of the whole box is worth 81. I have the areas of all of these individual triangles that I've colored in the pink, but I want to know this leftover space here in the trapezoid. So my final step, step 4, is to take my area of the box and subtract my area of the triangles. Is my final step. So the box area was 81. And I need to subtract all of the triangles, which means I'm going to have to add these all up and then subtract them. So 28, 3, 6, and 5. I'll add them all together. You get 42. And 81 minus 42 gives me that my final area is 39 units. And it's squared because we're talking about area. Okay. So because I've been talking for 30 minutes, I'm going to not do example 3 and example 4, but what I am going to do is show you my final answer. So if you want to pause the video here and give those two a try, you can, and then I'll show you my answer. So for example 3, I did the box method for this one just because it was easy peasy. So I found the area of my box to be 6 times 12, which was 72. And then I found the area of the two triangles that were left over, which just so happened to be the same because this is a parallelogram. So I took my square and I subtracted all the triangles from it, and I got a total of 36 units squared. And again, units squared because we're talking about area. Okay, and then if you want to give number 4 a try, you can pause the video, try now. I used the distance formula for this one just to show you that you could still do it that way too. But if you like the box method, stick with that. So for number 4, I knew to find the area of a triangle. The area of a triangle is base times height divided by 2. So what I decided to do was find the base and the height, and these are my base and height because this one's my height from Q to T because it's like a straight line, it's not slanted. So that is one thing to kind of notice as you're trying to figure out the heights. So I did the base here is 5.7, the height here is 8.5, and then I just plugged in base times height divided by 2. You could have used the box method. Obviously, that would have worked as well. Personally, I think the box method is easier than trying to figure out these, but I wanted to show you that you could do it either way, and you should still get the same answer in the end. So now from here, my dears, thank you for taking your notes. You are now going to do your practice worksheet, and then you're going to do your IXLs. So have at it and have some fun, and hopefully this was helpful for you. And that's all I got. And this is awkward now because now I'm still on. Okay, bye.